In today's lesson, we are going to look at solving quadratics by completing the square. So this is going to be, again, similar to the previous lessons where we are trying to determine different or to determine different values given other values in our quadratics. In the previous lesson, we looked at how to do that by factoring. Today, we're going to look at how to do it by completing the square. So in our first example, a rock is launched from a slingshot. Its height, h at t in meters, as a function of time, t in seconds, is given by h at t equals -5, t minus 2 squared plus 22. We want to know when does the rock hit the ground. Right? So we've done this with factoring. Right? We've looked at for the x-intercepts. Right? When it hits the ground, we're looking for when the height is 0. Or when h at t, the function, equals 0. Now, in the past, we might look for the x-intercepts, but in this case, we're given the vertex form. So we can't really go through and find the x-intercepts just by looking at it or factoring it, because it's not factored. We could go and convert it back to standard form and then factor it to find our x-intercepts, but that's a little bit of a time-consuming process. So what we can do, though, is very similar to what we've done in our previous lessons. Let's set this equation equal to 0. So 0 is going to equal -5 t minus 2 squared plus 22. So now what we're going to do is now we're going to try to solve for t. We're going to try to isolate / solve for t. So if I go through and do that, I need to move some of my terms to the other side. So I'm going to move my separate terms. So I'm going to move the plus 22 over. It's going to become minus 22. I have -5 times t minus 2 squared. I'm going to divide everything by -5 on both sides. One side will cancel out. I'm left with 4.4 is equal to t minus 2 squared. Now, if I want to solve for t, I need to get rid of the squared, so I need to square root both sides. One side, the square and the square root will cancel out, and I'm left with 2.098, which will equal t minus 2. Now, one thing to keep in mind, and we did touch on it in the previous lesson, if I square root a number, I actually get a plus and a minus answer to that. So what we're going to do is we're going to now look at two different scenarios. One, we're going to look at positive 2.098 equals t minus 2. And we're going to look at negative 2.098 equals t minus 2. So we're going to look at two different scenarios now with our two possible answers. So if I have positive 0 or 2, if I have positive 2.098 and I bring this value over, it becomes plus 2. I get 4.098 equals t. And for the other one, it's negative. If I bring a negative over, it becomes a positive. So I get negative 0.098 equal to t. So that means I have two solutions. The height will be 0 when the time is either negative 0.098 or when it's 4.098. Because we can't have negative time, we ignore this value because it is negative. Only because it's dealing with time. So then therefore, the rock hits the ground after 4.098 seconds. So kind of, again, we're trying to find a solution for a given given value, right, or for a given situation. Right? Very similar to the other ones that we were doing. We're just given a different equation. At what time is the rock 5 meters above the ground? So again, this is going to be very similar to some of our other scenarios. This is asking for when h at t is equal to 5. So we're going to do the same thing in our other scenarios. We're going to plug in 5 into our equation for h at t. So let's scroll back up. So h at t is going to equal, or 5 is going to equal negative 5 t minus 2 squared plus 22. Now we're going to go through our similar steps. We're now going to try to isolate / solve for t. So same kind of steps. We just, instead of 0 on the one side, we have 5. I'm going to bring the 22 over. It becomes minus 22. So I have negative 17 is equal to negative 5 t minus 2 squared. Divide both sides by negative 5. One side will cancel out. If I divide 17 by negative 17 divided by negative 5, I get 3.4, which is equal to t minus 2 squared. I need to square root both sides to cancel out the square root of the 2. The square root of 3.4 is 1.844, which will equal t minus 2. However, again, keeping in mind that when we square root a number, we actually get two solutions, so it's plus minus 1.844. So I'm going to use those two different values. Positive 1.844 equals t minus 2, and negative 1.844 equals t minus 2 into our, and we're going to have basically, we're going to look for two different solutions. So again, because of the square root, there's two different possible solutions here. So I go through and solve, move the minus 2 over, it becomes plus 2, so 3.844 equals t, and the other one, move it over, it becomes plus 2, and I end up with 0.156 equals t. So this means that none of these answers are negative, so these are both good. Right, so they're both usable, right? I'm not going to ignore any. So therefore, the rock is 5 meters above the ground at 0.156 seconds and 3.844 seconds. So again, just understanding that it's reaching this height two different times. The last one, or the last question, is what is the height of the rock, or from what height was the rock launched? So this is basically asking, what is our y-intercept? When we're looking for our y-intercept, or basically when x is equal to 0, or in this case, when our time is 0. So this is a little bit easier because we don't have to worry too much about actually going through and rearranging or solving for too much. We're just basically saying, what is the value of the function when t is 0? So we're going to replace t with 0 in our equation and go through and solve. Negative 5 times negative 2 squared plus 22. We get negative 5 times 4 plus 22. We get negative 20 plus 22, or 2. This then means, therefore, the rock starts 2 meters above the ground. D, a little bit of a different question. How long is the rock greater than 15 meters above the ground? So if we want to go through and do this, we need to go through and determine when is the rock 15 meters above the ground. And then we can use that to figure out how long. Actually, there may be a little bit of a typo in this question. Let's just change it to 5 meters just to keep it consistent. And we'll just keep it with our same answers that we got from part B. Right, so it saves us a little bit of some calculations from doing the same things over and over again. Still gives us a different type of question. So from part B, the rock is at 5 meters at 0.156 seconds and 3.844 seconds. So if I want to find out how long it's greater than that height, right, I can take those two distances, or those two times, sorry, subtract them to find the difference. And that will tell me how long it's above that height. Therefore, the rock is above 5 meters for 3.688 seconds. And the reason we can do that is because if I draw a quick diagram, we know it starts at 2 meters, the rock goes up, it comes back down. If I know the 2 points, or the 2 times, when it's above or when it's at 5, right, so 0.156 and 3.688, the difference, or that length of time from one to the other, is going to be the times that it's above that height. So that's how we can use sometimes our answers to determine how long something is above those heights. In our next example, a football is kicked and the height of the football is modeled by the function h at t is equal to negative 5t squared plus 20t plus 0.5, where t is the time in seconds and h at t is the time in meters, or the height in meters, sorry. We want to know what is the maximum height of the football and at what time does it reach this height. So because we're talking about a maximum, we are talking about the vertex. Now this equation is in vertex form. The other one was, so we could have looked at the other one and just found the vertex from that form. However, this form is not. This is the standard form. Right, so again, just a reminder, this is standard. And in previous lessons, we've learned how to go from our standard form to our vertex form. Right, so this is our previous unit. We did learn how to go from standard to vertex. We need to complete the square. Right, that was the method we used to go from standard to vertex. So if we start off, h at t is equal to negative 5t squared plus 20t plus 0.5. The first step was to put brackets around the first two terms and then factor out the value in front of the squared variable. So I'm going to factor out a negative 5, t squared minus 4t plus 0.5. From there, I needed to find my magic number. My magic number was the second term in the bracket, so negative 4. I'm going to divide that by 2, and then I'm going to square it. So negative 4 divided by 2 is 2, or negative 2. And then when I square that, I get 4. So 4 is my magic number. That is the value that I'm going to add and subtract inside the bracket. So negative 5 times t squared minus 4t plus 4 minus 4, 0.5. This negative term is going to move to the outside, and I'm going to reapply that factor that I took out. So I'm going to multiply it by negative 5. Negative 5 times t squared minus 4t plus 4 is still in the brackets, plus 0.5 plus 20 from the negative 4 times the negative 5. And now I can factor my bracket, which will be a perfect square trinomial. So t minus 2 squared plus 20.5. And now I have my vertex form. So with my vertex form, now I can go through and I can find my vertex. Right? The vertex is 220.5. And from there, I can say, therefore, the max height is 20.5 meters. And it reaches this height after 2 seconds. The x value of the vertex is the time. The y value is the height. Now for our next part, at what time is the football 3 meters above the ground? Because we've learned of a different way, right? We're not going to worry about factoring and going from our standard form. Right? We can look at our vertex form, which might be a little bit easier to solve because we don't have to do any factoring. So I'm going to take my vertex form, h at t is equal to negative 5 t minus 2 squared plus 20.5. If I want to find the time that the football is 3 meters above the ground, that is the h at t is equal to 3. So I'm going to replace that with 3. And I'm going to go through and solve similar to how I did it in example 1. I'm going to move this separate term over, or I'm going to now isolate / solve for t. So I move that 20.5 over, it becomes negative 17.5 equals negative 5 t minus 2 squared. Divide both sides by negative 5. One side will cancel out. Get 1.871. Sorry, no, not that. I get 3.5 equals t minus 2 squared. To cancel out the squared, I need to square root both sides. And hopefully these steps seem familiar from the last example. When I square root 3.5, I get 1.871 equals t minus 2. Remembering that when we square root a number, we actually get a positive and a negative version of that. So now this is where I split and then look for two solutions. Positive 1.871 equals t minus 2. And negative 1.871 equals t minus 2. Move the negative 2 over, becomes plus 2. I get 3.871 equals t. And for the other one, negative 1.871 plus 2, I get 0.129 equals t. So therefore, the ball is 3 meters above at 0.129 seconds and 3.871 seconds. So in two different times, it's at 3 meters. C. Again, just for sake of ease of question, I'm going to change it from 2 to 3 so we can keep consistent with our other one. Right, so we can go through and use the same answers from the last one. Right, so from part B, our two answers for when the ball was at 3 meters, it was 0.129 seconds and 3.871 seconds. So again, similar to the last example, if I look at my graph, football gets kicked at two different points. Is it 3 meters above the ground? .129 and 3.871. So if we want to figure out how long it's above 3 meters, I'm going to look for this section, which will just be the difference between the two times. So 3.871 minus 0.129 gives me 3.742. So therefore, the football is above 3 meters for 3.742 seconds. Our last question, again, similar to the other one, when does the football hit the ground? So again, this is basically asking for our x-intercepts, or when the height, or when h at t is equal to 0. We could plug this into our standard form and go through and factor, although I feel like this method of using the vertex form of h at t is equal to negative 5t minus 2 squared plus 20.5, going through replacing h at t with 0 and now going through and solving for t might be a little bit easier because it ties in a lot of our solving equations. So if I go through, rearrange, this 20.5 comes over, becomes negative 20.5 equals negative 5 t minus 2 squared, divide by negative 5 on both sides. One side is going to cancel out. We're going to get 4.1 is equal to t minus 2 squared. Need to square root both sides. Cancel out. Get 2.02 equals t minus 2. Again, because we square root, we get two answers. A plus 2.02 and a minus 2.02. So I'm going to break this up into two parts. Plus 2.02 is equal to t minus 2. Bring that over. Becomes 4.02 equals t. And the negative 2.02 equals t minus 2. Bring that over, we get negative 0.02 equals t. We can ignore that second answer because it is negative. We can't have a negative time. So therefore, the football will hit the ground .02 seconds, or we say after 4.02 seconds. So a lot of this is similar in concept to what we've previously done, right, in the previous lessons, by plugging in values that we're or one of our values, or we're replacing one of our variables with a value, and we're going through and solving. This one's different from the previous lesson because we're not going through and factoring. We're either using the vertex form and rearranging and solving for t, or we're completing the square to get vertex form and rearranging and solving for t. So similar concepts, similar ideas, just applying some of our solving equations knowledge with completing the square. So again, make sure you are practicing, make sure you are reviewing, so that you become comfortable with this process.